Hello students, now we are going to see how we can add two 16-bit numbers using 8051 microcontroller in KEIL µVision simulation. We will be using KEIL µVision version 5 for simulating the addition. Ideally the 8051 or 8085 are 8-bit processors or microcontroller. That means the size of the accumulator is 8-bit and the data bus is also 8-bit, but the address bus is 16 bits, and 8051 Intel 8051 that has actually 8-bit of accumulator, and it has 4 kilobytes of code memory or ROM and 128 bytes of data memory, or we say RAM or internal RAM. But address bus size is 16-bit, and one pointer is given, that is DPTR, one register we can say, that can be used, that is of 16-bit size, that can be used to fetch any data from the code memory section, that is from ROM, as it is 16-bit address or a 16-bit register. It can contain 16-bit values. So for this program, what we are going to see, that the numbers, the two 16-bit numbers that are stored in ROM, that is the code memory in the ROM section, and we want to fetch those two numbers and then do the operation like add or subtract and store the result in internal RAM. For that purpose, and this is going to be difficult than all the things in internal RAM, but we are considering this difficult one. Then in another video we'll show how we can do this when all the numbers and the results all are in internal RAM. So for this, how we can store the numbers, because the memory is 4 kilobyte, that means there are 4K 4094 memory location. Each location can contain 8 bits of memory, that is 1 byte. Now we are considering 16-bit, that is 2 byte. So each number will take 2 memory locations. So we divide the number into two parts. One is the higher byte and the lower byte. So if the number is 1 2 3 4, then this 3 4 becomes the lower byte, or we say LSB, least significant byte, and this 1 and 1 2, this 8-bit, that is 1 byte, that is the higher byte. So each number has to be stored in two memory location. So what this section is telling, this section of the code, that org100H, that is we are in the ROM section, there is 0100 16-bit address. In the memory address, the very first memory address will store defined bytes. That means in that particular memory location we shall have 78 hex, this value, and that is the number one low. That is the number one is number one low. So here actually this is number 2 and this is number 1, or we can say rather number 1 is 5678 as per the code I am telling, 5678, and number 2 is 1 2 3 4. So that is number 1 and number 2. As we are changing only in the comments, so I don't need to build again to run this. But if I am changing anything in these values in the code section, then I have to build the code again once again. There is the assembling part is to be done once again before running or before debugging. So that is how we store the numbers. So each number will be stored in two locations, and the results for a 16-bit operation, the result will be also of 16-bit, though maybe the subtraction result may not be, but we will consider it may or may not be. So it is better to have allocate 16 bits, that is 2 memory location for the results. So for the summation, that is addition result, we will have to assign 2 memory location to store the result, that is we have assigned 30 and 31 each. because our internal memory, general purpose uses memory, starts from 30H. So we kept the result of the summation addition, the lower byte will be kept at 30H and the higher byte will be kept at 31 hexadecimal memory location. Similarly, for the subtraction result, lower byte will be at 32 and the higher byte will be at 33. This is the initial setup where we'll get the data, the two number, and where we'll store the results. Now the code how we'll do. So we'll, before that we'll just build the target, and this is done. It's showing this 0 error and 0 warning, so it is done. Now how we'll do, we'll go to this debug window. So once you click this okay, this will come as the debug window opens, and we need to check two area. As soon as I run this for the simulation, this part is done, that is 100 0 and 00 memory location in the ROM. These bytes are defined, that is in 100 100 location there will be value 78, in 101 56. These values will be stored. How we can see? We can see from the memory window. If we go to memory window, then in the address we type C:, that is the code section. I am referring to the ROM, C:0x0100. That is this address, initial address. So then enter. What I see that the memory map from this particular address 0x100, and this is the 100, this is 101, 102 and 103. I can see that these are loaded, these values are already present in ROM. So this is the first number 5678 and the another number is 1234. So these two numbers are saved. Now for this is kind of a variable assignment, so we will not see anything in there, but we need to open the code data memory. So in the memory window 2 we have opened D:0x30, that is 30H, starting from 30H. So for the timing it is 00L0, but as soon as we complete this program we will get the result in this 30, 31, 32 and 33. So summation result 30, 31 and 32, 33 will get the result of the subtraction. So let's start the coding. So what we will do, we will use F11, this button menu, to go one by to debug one line at a time. So one line. So in the main program we started in the first line, that is move DPTR number 1L. What this line is doing, it is basically the number 1L, that is the address of the first number lower byte, that is stored, the value is 78 and stored at what location? 0100. So DPTR will be loaded with this value 0100. So as soon as I complete executing this line, I will see the value 0100, that is 0x0100, this value at DPTR. So this value is loaded. Now I am clearing accumulator. We will see why this is required. Clearing means accumulator becomes 0. Now accumulator is 0. Now what I am doing, using MOVC instead of move. When we are moving data from internal memory where address is 8-bit, we use move. But this time we are taking the value from the ROM, that is the code section, the 16-bit address. So we are using MOVC, move value from the code section, that is for the C. MOVC A, @ A plus DPTR. Now A is 0, already we have cleared. So 0 plus DPTR, that is actually the value remains same, that is 0x100. So move the value that is present in memory location 100 at ROM to accumulator. So as soon as I execute this line, so 100 memory location has this 78 value, that value will come to the accumulator. So this line will make 78 to load in the accumulator. So now accumulator is 0. Once I execute this line, the accumulator will have 78. Now what I am doing, I am now moving this value to some other register, that is R4. It can be anything, any other register, because I need to again load the second number. So first number is the lower byte of the first number is stored in R4. Now for summation, what is our algorithm? Algorithm is that first add the lower bytes, then add the higher bytes. While adding the lower bytes, keep in mind that if you have encountered an carry, that is the addition of the two lower bytes, is more than FF, then there will be one carry. So when you are adding the higher bytes, you need to add one more. That is, you have to use the add with carry. Instead of add add, you have to use the instruction addc, add with carry, for in the higher byte part. So in the lower byte part, now we are loading the second number, that is the lower byte of the second number. So that is present in the lower byte of a. This is the number 12. So lower bytes of the second number is stored in, the value is 34H and stored in, this is 100, this is 101, this is 102, 102. So 102, that is defined by number 12. So number 12 will load DPTR. So in the DPTR we will loading number 12, that is 102. So as soon as do this, DPTR becomes 102. Now again clearing accumulator. Now MOVC A, at DPTR. That is the value present at number 12, that is 102 memory location. The value is actually 34. So this 34 value will come to accumulator. So as soon as I execute this, 34 accumulator value is 34. Now what we'll do? We'll do this add A, R4. We'll add these two values. So this is done. The result will be present in accumulator. The result will be this 78 plus 34, that is AC. So result is AC in the accumulator. Now we'll save this value, and this is the sum of lower bytes. So sum will 30H in the memory location 30H will, this will be stored in memory location 30H. So this is executed. So now we can check memory location 30H. We will see that the value is stored. Memory location 30H, the AC is stored. That is the sum of the lower bytes, and there is no carry. So how do we check there is no carry? You can see the PSW carry bit is 0. Otherwise also what we are doing, we are to store the carry, we are dedicating this R6 register. Initially we are clearing the R6 register, that is loading 00 in the R6, that is the R6 becomes 0. In the next line we are doing JNC no carry, that is jump if no carry. So we have no carry, so it will jump to no carry level, this portion, this code. If there was a carry, then R6 will be incremented. INC R6 means the value of the R6 will become from 0 to 1. But in this case we have no carry, so we will go to this line. So let's see, right, JNC no carry, and then we reach this line. Because JNC no carry, it will come to this no carry level. This is the first instruction. Now we need to load the higher bytes. The same thing, the first address of the higher byte will load, that is 101. This address will be loaded in the DPTR. Then we clear the accumulator. Then using MOVC we will get the value in accumulator, that is 56. The higher byte of the first number 56, higher byte of the first number 56, lower byte higher byte of the second number is 1 to 12. So we get the 56 in, then we transfer this 56 to R4. So do this, so accumulator is 56. Now we transfer this value to R4. So in the R4 we have the one number, that is the first number. Now what we want to do, we want the second higher byte of the second number in accumulator. So do in the same way. So we are doing, and we get the accumulator loaded with the higher byte, that is 12. Now we need to simply add this A and R4. R4 contains the higher byte of the other number and A has the second number. So we simply add. In this part we need to use add C, that is add with carry. In this case we have no carry, but it might have happened that we have a carry. So in that case we have to, when we are adding the higher bytes, we need to add that carry. Add C does that for us. So we don't need to manually add. This add C will do. If there is a carry, it will automatically add the carry. Instead of add, we need to just use this add C, add with carry. So now we are doing this line. Done. Now the result is 0x68, that is 68H. That is the summation of 56 and 12, that is 6 into 8 and 5 and 1, 6, so 68. This result will be stored in some high, that is addition higher bytes. So okay, done. Now you can see there this 68 is come to 31H location. So this is addition is done. Now for the subtraction, exactly same thing will happen, and I am not going through all this. The same thing is happening. First load the first number, move to R4, that is actually first load the second number, because we are going to do number 1 minus number 2. So first load the second number, then store the second number in R4, then load the first number. Then first number will become in the accumulator, then we write subbb subtract with borrow a comma r4. That is, the a contains the first number and r4 contains the second number. So we reach the sub. So done. The result will be in the A. So what will be the result? Number 1 lower byte is 78, number 2 lower byte is 34. We do the subtraction, we get 44. So this will be in the A register. So accumulator we see 44. Now we are moving this 44 to results lower bytes. Diff L points to the results lower byte, that is this 32 location. So as soon as I execute this line, the result comes to this. Now what we have to do, we have to check if there is a borrow, but in this case there is no borrow. But if the first number is lower and second number is larger, we are subtracting higher value from the low value, then there will be a borrow. So we need to factor in. So in that case, this AC and CY, this will contain 1 1. You can try this on your own, and if you face any problem you can comment, then I will try to solve for you any problem you encounter. Now again coming to the second number, we load the second number. Okay, so we load the first number is in R4, and now the number 1 is loaded. Now we have number 1 is 56. We see accumulator contains 56, and the another number is already 12, that is in R4 contains 12. If we do the subtraction, 56 minus 12 SUBB, result will be again 44. So we are doing this, and this is done. Result 44 stored in the accumulator. Now this value will go to difference high, that is the subtraction results high bytes. So as soon as I execute this, the result will be D5. You see this 44. Now this is the result of subtraction 4444, and result of summation is 68 AC. So this is done using ROM. The values are taken from ROM. Next, in the next video I will show how we can do this in a simpler way. There no MOVC will be required or no DPTR will be required. How we can do this in everything in RAM, internal memory. That we will see in the next video. Thanks for watching, and please make comment if you try yourself by changing these values like lower value and higher value, so that you can encounter carry while addition and borrow while subtracting. Then you check the results. If you face any problem, you can comment, and I will try my best to solve your problem. Thank you.